Hello everyone, welcome back to lecture number 4 of the week 8. In the lecture 1st, 2nd and 3rd of week 8, we had seen that successive differentiation and examples on the successive differentiation as well as Leibniz theorem and its proof by the mathematical inductions. Using the Leibniz theorem, some of the problems we had already established and we had solved those problems using those Leibniz theorems. And we have seen that using Leibniz theorem, those problems will become more easier to solve. Otherwise, it will become a very hard to or tedious things to do the successive differentiation and solve those problems. Now, in the present lecture, we will go for the exercises in successive differentiation, and in on upcoming lectures, we will do the exercises on Leibniz theorem. So, let me start with successive one. So, first problem, as you can see here, it says that find out the nth derivative yn. Yn, I think you have remembered the symbols of the nth derivative. So, nth derivative of y equal to f of x, we had used yn or d of fn, where d and fn, right? And these are the two symbols. There are various symbols you can use, or you can use f of n and so on. But we had used these regularly to a custom with ourselves. So, find yn, that means find the nth derivative if y is given sin square x into cos square x. Now, look at in those problems, these problems are with two trigonometrical functions in the product. So, the product of the two trigonometrical functions, and we knew that we can convert these problems in a single type or where we can have no product of those things. So, we try to find out, or we try to convert these sin square x into cos square x in a some trigonometrical functions where product is missing, right, where product is absence. And why we are doing this? Because we knew the y equal to cos ax plus b, nth derivative of y equal to cos ax plus b. Similarly, we knew that y equal to sin ax plus b and its the nth derivative, and so on. So, that is why we try to transform this problem into some trigonometrical function in a specific sin x or cos x, so that we can use directly the formula we had already derived. So, y sin square x cos square x can be converted into 2 into sin x cos x ka whole square, and since 2 square is equal to 4, so I have to multiply and divide by 2, right. So, this is 1/4 into 2 sin x into cos x ka whole square, and 2 sin x cos x we knew that, right, sin 2 theta. So, this will become sin 2 theta sin 2x ka whole square, and this is 1/4. Now, sin square theta can be converted and use the formula 1 minus cos of 2 theta divided by 2, right. So, sin square of theta can be written as 1 minus of cos of 2 theta by 2. So, use this formula, 2x become 4x, 1 minus cos 4x and divided by 2 into 1/4, and this is simplified in 1/8 minus 1/8 into cos 4x, right. Now, as you can see, there is a single problem, the single trigonometrical function exists. One is the constant, that is the 1/8, and other is the cos 4x. And we knew the cos y equal to cos ax plus b, the nth derivative of that cos ax plus b, right. So, we are going to use directly of this. So, yn, the constant function. So, let me give you. So, y equal to 1/8. What is the y1? y1 equal to z. What is the y2? y2 equal to z, and so on. So, yn equal to 0 after the first one, right, or since the first one. So, that derivative constant is nothing, but nth derivative is going to be 0. Now, cos 4x, we knew that y equal to cos of ax plus b, then nth derivative y of n is equal to how much? an cos of ax plus b plus of n pi by 2, right? Using the same thing here. So, cos 4x here a become 4, b becomes 0. So, 1 by 8 ap power n is here. So, 4 p power n cos of ax plus b 4x plus of n pi by 2. That will be our answer. And you can you can just modify it. 1 by 8 can be written as 2 p power minus 3. So, use this formula. So, it will become minus 2 n minus 2 cos of 4x plus of n pi by 2, right. So, that is how we had reached at that conclusion, right. Let me, I had some problem here. So, 1 by n into 4n, right. So, you can have this 1 by n into 4n, that is equal to 1 by 2q into 2 cos square, 2 cos square into n, right. So, this will become 2 into of n minus of 2, right. That is how we can deal with this. And let me again give you the another problem where yn is equal to ex sin square x. To find the nth derivative when y equal to ex into sin square x. Now, look at this problem. This problem is the product of the two functions. The first function is exponential function, and the second function is trigonometrical function, right. I will try to firstly convert this sin square x, because we have not derived y equal to sin square x the nth derivative. So, what I have to do, I have to convert this sin square x into the single trigonometrical function, or you can say in the linear case y equal to cos x or y equal to sin x, something like that, right. So, we will do this. So, y equal to ex sin square x can be written as 1 minus of cos 2x. We had seen this sin square theta is equal to 1 minus of cos of 2 theta by 2, right. So, use this formula. This will comes out to be ex by 2 minus of ex cos 2x 2. So, we knew the nth derivative of such functions, and how you can imagine this one. So, we had derived the nth derivative of ex, and 1 by 2 is the constant one. So, that is the y equal to ex, the nth derivative is equal to the same one, right. So, yn equal to ex. So, the first nth derivative is the same one, ex by 2. Now, the second one, using the formula ex into cos 2x by 2. So, finding out the ex has the nth derivative as ex, and cos 2x is 2x plus n tan inverse 2 divided by 2. But how to find out the an, right? So, this will becomes out to be half of ex 1 minus of 5 power n by 2 cos of 2x plus n tan inverse 2, and that will be your answer. Similarly, can you find nth derivative of y equal to 1 plus of x to the power minus 2? That is the question. So, nth derivative of y where y equal to 1 plus x minus 2. Use the successive differentiation. So, y1 is nothing but minus 2 into 1 plus of x and power minus 2 minus 1 equal to minus 3 into 1, right. Similarly, y of 2 equal to minus 2 into minus of 3 into 1 plus of x and this minus 4 into 1, and so on. So, that will give you yn equal to how much? Minus 2, minus 3, minus 4 and till minus 1 plus n, 1 plus x to the power minus 2 plus n. And how you will sure that this will be the term? Look at here. So, the second term containing what? Second terms containing the two terms, and the last term is minus 3. So, that means minus 2 minus 1, right. So, that means minus 1 plus of 2. I can write this one. So the nth term is nothing but minus 2 starting with this minus 3 and till minus of 1 plus of n. That's the answer. And how much this value? As you can see here, 1 plus x minus 4 and this one is minus 3. So 1 plus x, so and then it will have minus 2 plus n, right? Minus 2 plus n, and that's your answer. So yn can be written as minus 2 minus 3 minus 4 till minus 1 plus n and 1 plus x power minus 2 plus n. This can be converted, and as you can see here, this is going to be a factorial one, 1 plus n factorial, but is it in the negative or positive depending on n? So minus 1 power n, 1 plus n factorial, and this can be written as 1 plus x n plus 2. So yn is simply nothing, if y equal to 1 divided by 1 plus x ka whole square, then yn is nothing but you have to 1 plus of x n plus 2, and the above becomes minus 1 power n into 1 plus n ka whole factorial. So that's your answer. Example 4, y equal to sine m into sine inverse x. Then prove that. There are two problems here. Firstly, there is an expression containing x and the higher derivative of y, right? So 1 minus x square y2 minus x y1 plus of m square y equal to 0. One of the way is to find out y2 first, then y1 first, and then what you will do, you have to multiply by 1 minus x square, then x, and then you have m square into y, and then what we will do, you just take the subtraction here, then addition here, and that will give you 0. That is the tedious way, right? You have to find out y1, you have to find out y2, and so on. The simplest way to do this is use the expression itself. So what is it given? As you can see here, it's given as y sine of m into sine inverse of x, right? So y1 can be written as d of sine m into sine inverse of x divided by m into sine inverse of x, right? Use the chain rule, and then d of m sine inverse of x divided by dx. That is the easiest way. So d of m sine inverse x, m into how much? M into square root of 1 divided by a square root of 1 minus x square, and this one become cos of this. So this will become cos of m into sine inverse x and into 1 divided by a square root of 1 minus x square, right? So that is what we will get here. And now this can be, take this outside here. So take this one from here. You will get 1 minus x square y1 is equal to cos m sine inverse x. And then squaring both sides. Take the squaring both sides. So y1 square 1 minus x square is equal to m square cos square m sine inverse x. So as you can see here, m is left here because this is the m. Now see this one. So let me change this color. Here, as you can see here, what was the dm into sine inverse x dx. So that will be giving you m into m divided by square root of 1 minus x square into cos of m into sine inverse of x. That is the way. So this will be comes out to be m of cos m sine inverse x, and squaring both sides will leads to y1 square into 1 minus x square is equal to m square cos square m into sine inverse of x. That is the expression we had here. So take m square, and this will gives you cos square. So that can be written as cos square theta is equal to how much? 1 minus of sine square theta. So use sine square m sine inverse x, and sine square m sine inverse x is nothing but it is, see here, sine m sine inverse x. So, it's nothing but it is y square. So, the whole equation will become m square into 1 minus y square, right. So, we had here 1 minus x square into y1 cos square is equal to m square into 1 minus of y square. Now, take the differentiation both sides again, because we need the higher y2. To prove this, we need y2. So, doing the same thing, take the differentiation both sides. This will give you how much? 2 into y2 into y1 into 1 minus of x square and plus of y1 cos square into of 1 minus x square. This will become 2x is equal to m square into how much? Minus of 2y into y1, right. That will be your answer. Simplify it very quickly. So, it will gives you how much? Y1 square. So, this will give you 1 minus x square into y2 minus x into y1 plus m square y is equal to 0, right. By taking y1, change this color. So, by taking y1 from the each equations both sides. So, this will comes out to be 1 minus x square y2 minus of x y1 and the 2 from the each side. So, minus x y1 here, and this will be m square y negative. So, it will comes out plus of m square y. So, that is your answer. Now, you can see that using the successive differentiation, it is easy, or using the existing results, it is easy to solve a given problems, right. Now, we can do for the second problem. Second problem is the nth derivative. Nth derivative is only occurs in a Leibniz theorem, isn't it? So, we are going to use the Leibniz one. So, using the Leibniz rule, what was the Leibniz rules? U into Vn is equal to written as UnV plus of NC1 Un minus 1 V1, right, V1 and so on, right. So, it will comes out to U into Vn here. So, doing the same thing, 1 minus x square yn plus 2 plus nc1 minus 2x yn plus 1 and nc2 minus 2 yn, and why we are using this? Because it has a 2 function here. So, here, right. So, using this one, it will gives you 1 minus x square yn minus 2 minus of 2n plus 1 x into yn plus 1 plus of m square n square yn is equal to 0. So, by the deriving the first one, we can reach at the conclusion for the second one, because we have taken the Leibniz rule in the first one itself, here itself, and this will give you the required result for the second problem. So, next one, find the nth derivative of sine 6x cos 4x. Again, there is a two trigonometrical function and both are in the product. So, we had given y equal to sine of 6x into cos of 4x. So, we can treat this one as y equal to sine A into cos B, and since it is in the product of the two trigonometrical functions, we can convert it to find out the individual sum or differences of the trigonometrical functions. That is our idea. So, sine A sine B can be converted in such a way that it is in the some sine theta plus of cos of theta, or some sine theta plus of sine another theta, cos of theta plus of cos theta, and so on, right. So, we use that one. So, y equal to sine 6x, this can be written as of sine A cos B, and it is coming in sine A plus of sine A B. So, right. So, we can write this one as sine of A plus B into plus of sine of A minus B, and this is divided by 2, right, because this is the result was sine A plus B plus sine A minus B equal to 2 into sine A into cos B. So, use this result. This will comes out to be sine 6x plus 4x sine 10x and sin 6x minus 4x sin 2x and divide by 2. So, taking sine of 10x as again y. So, yn can be written as and take this and as a sine of ax plus b. So, yn can be written as a power n sine of ax plus b into plus of n pi by 2. That was the answer. So, here a is equal to 10, b equal to 0. Use this formula. So, this will comes about half of 10 to the power n, right, sin 10x plus n pi by 2. Similarly, here you will find out 2 to the power n into sin 2x plus n pi by 2, and that will be your nth derivative of that function, right. So, this is the required nth derivative of a given function which has the product of the two trigonometrical function sin 6x and cos 4x. Now, look at the sixth problem. Find nth derivative of sin square x into cos qx. Initially, we had seen that sin square x into cos square x, right? And what was the answer? If you remember that one, the first problem here, sin square x into cos square x. We had converted this problem in a single function or addition or subtraction in the form of trigonometrical function, that is 1 by 8 minus 1 by 8 cos 4x, and the answer will become minus of 2n minus 2 cos of 4x plus n pi by 2, right. Now, the question has been changed slightly and it has been asked that find not only sin square x cos square x, but here the y is different and it is given sin square x into cos qx, right. So, the power of cos is higher than the sin, and now we will do the same thing. Firstly, we will use sin square a into cos square cos cube b, and then use the formula to find out somewhere in a another trigonometrical function, and then change that trigonometrical function in a single or addition subtraction of the single trigonometrical functions. So, sin square x cos qx can be written as sin square x into cos square x, this one, and cos of x. Sin square x cos square x we had seen in the previous one, 1 by 4 sin square 2x, and this one is the cos 2x. So, this has been converted, the first one has been converted 1 by 8 into 1 minus cos 4x into cos x, right, and then multiply each other. So, the first one become 1 by 8 into 1 into cos x. So, 1 by 8 into cos x, the second one will become cos 4x into cos x. Now, use this one cos a into cos b, right here, and then convert this whole problem in single one addition and subtraction. So, this will become 1 by 8 into cos x, and this one become, as you can see here, what was this, cos a cos b. So, this will become cos a plus b plus cos of a minus b. So, cos of a plus b and plus cos of a minus b, right, and 1 by 2. So, that will become 1 by 16 into cos of 5x plus of cos 3x. So, this will become, take this one 1 by 16, then it will become 2 cos x minus of cos 5x and minus of cos 3x. Now, we knew the nth derivative of cos x, cos 5x, cos 3x, right. So, this will become 1 by 16 as a common, and this is 2 into cos of x plus n pi by 2, the nth derivative of this function. This nth derivative of the function is what, 5 pi power n into cos of 5x plus of n pi by 2. Similarly, this one become 3 pi power n into cos 3x plus n pi by 2. The answer is in the addition of all these expressions, all three expressions, right, and therefore, the nth derivative of a given function, that was sin square x into cos qx, this one. sin square x into cos q. X is nothing but 1 by 16 2 into cos x plus n pi by 2 minus 5 pi power n cos 5x plus n pi by 2 minus 3 pi power n cos 3x plus n pi by 2. That is the required answer. So, as you can see, these are the some simple problems based on the successive differentiation. If we were not using the successive differentiation, it will be hard, it will be quite difficult or mathematically complex to find the solutions directly using the successive differentiation. So, using the successive differentiation and the result which we had already derived for some standard functions, that will help us to find out the problems given in a required form. So, I believe that it will boost or enhance your concepts in the successive differentiation. Thank you so much.